Hello, welcome again to Virtual Space 3D. I'm Amanda Bush. Our monthly reports bring you the latest news on exciting progress in the commercial development and scientific exploration of space. In this month's show I will talk about Orbital Sciences launching a cargo flight to the International Space Station, and about SpaceX's launch of 6 satellites and returning the Falcon 9 first stage for a soft landing. I'll also highlight a new Russian launcher, discuss the culprit that's making Martian gullies, and finally I'll talk about 2 comets coming and going in our solar system. On July 13th, a shipment of cargo left the Virginia coast for the International Space Station. An Orbital Sciences Antares rocket lifted off with a Cygnus cargo module from a commercial spaceport adjacent to the NASA Wallops Island facility, where for decades only suborbital rockets were fired. The launch had been delayed for about 6 weeks following the explosion of an engine on a test stand in Mississippi. The Antares engines, believe it or not, come from the Soviet moon program of the 1960s. Although the engines on this rocket had been tested, they needed to determine the cause of the failure and inspect the engines on the rocket to ensure they would not suffer a similar failure during the launch. Fortunately, the launch was problem-free and the Cygnus reached orbit and 3 days later berthed with the station. Over 1,600 kilograms of food, water, equipment, experimental materials and other items were delivered. There were also 28 nanosats from the company Planet Labs that will be shot into orbit from the Japanese module. Planet Labs eventually will have enough satellites in space to take images of every spot on the Earth once a day. The Cygnus will stay at the station for about a month and then leave with a collection of trash and burn up in the atmosphere over the South Pacific Ocean. Just a day after the Antares launch, another commercial rocket took to the sky. The SpaceX Falcon 9 rocket lifted off from Cape Canaveral on July 14 and successfully placed 6 Orbcomm satellites into orbit. After the first stage of the Falcon 9 separated from the upper stage, it reoriented itself and fired 3 of its engines to reverse course and slow down from hypersonic speeds. It eventually came down through the atmosphere and it fired one of the main engines to slow it sufficiently to make a soft landing upon the sea. A video released shows the view from a camera looking down from the side of the rocket. Despite ice crystals on the camera lens, it clearly shows the legs being extended as the rocket comes down to the water. Once the rocket was in the water, it tilted over and broke up. However, the test showed for the second time that the first stage can return from high-altitude hypersonic speeds down to a soft landing. The company plans to make an attempt in September to land on a barge at sea. Later in the year they will attempt to fly a first stage back to the Cape for a landing on hard ground. They believe the booster will need only minimal refurbishment to be flown again. If true, the company will be able to achieve 50% or more in cost reductions for launches to space. Russia has continued to launch the Proton and Soyuz rockets developed decades ago in the Soviet era for its large unmanned and manned payloads. Though improved many times over that period, the technology of these rockets is clearly not state-of-the-art. Russia decided in the 1990s to develop a new family of rockets called Angara that will gradually replace these legacy systems and become the primary means for putting Russian payloads into orbit. The Angara system is built around a core rocket module that can launch on its own for small payloads or be clustered with multiple modules to provide sufficient power to put as much as 37 metric tons into space. The propulsion system uses liquid oxygen and kerosene, a much cleaner combination than the toxic propellants used for the Proton rocket. Funding problems have long delayed the development, but the first Angara rocket finally made its maiden flight on July 9. The suborbital test launch of the Angara 1.2 from the Plesetsk Cosmodrome in northern Russia was deemed a success. An Angara 5 heavy lift rocket has now been shipped to Plesetsk and is expected to put a payload into orbit later this year. Back in February and March we talked about gullies formed on the sides of hillsides on Mars. There was some indication that perhaps some of these were formed by water ice melting in the sun and salty enough to avoid instant evaporation in the very thin Martian atmosphere. A group at the U.S. Geological Survey studied before and after images taken by a camera on the Mars Reconnaissance Orbiter of 38 sites with active gully formation. They found that the timing of the activity coincided with seasonal carbon dioxide frost and temperatures that would not have allowed for liquid water. So rather than water, it appears that the movement of the surface matter comes from the cycling of carbon dioxide in the atmosphere as it freezes into dry ice during extremely cold periods and sublimates back into gas in less cold periods. It is still possible that in some special cases, water ice causes small surface movements, but it is dry ice causing most of the sliding around on the red planet. The European Rosetta spacecraft was launched in 2004, and after passing by two asteroids in 2008 and 2010 it went into hibernation. Last January it was awakened to prepare for its encounter this August with the Comet 67 PCG. Rosetta will orbit the comet and place a lander on the surface as the object plunges in towards the Sun. The mission will be in position to monitor the comet as it starts to heat up and produce the coma of particles that gives a comet its tail. As Rosetta has approached the comet, its shape has gradually come into focus and it looks very strange. Instead of a single big rock, it looks more like two big rocks stuck together. Some wags have called it a giant rubber ducky. Maneuvering the lander into a safe spot may be a challenge. The mission to 67 PCG looks to be quite a show. Comet sighting spring is heading away from the Sun rather than towards it. We reported in May that the comet sighting spring will pass Mars this October. The nucleus of the comet will come within 132,000 kilometers of the surface. The coma particles evaporating off the comet, however, could come much closer. In fact, some might hit spacecraft circling the planet, such as the Mars Reconnaissance Orbiter. Though small, the particles are going fast enough to cause severe damage. NASA announced that its spacecraft are being maneuvered to be on the opposite side of the planet at the time of the comet's closest approach. While avoiding the worst threat of the comet dust, controllers on Earth nevertheless will take advantage of this scientific opportunity and use the cameras and sensors on the spacecraft to study the comet's nucleus and learn more about its composition and structure. The cameras should produce spectacular pictures of a comet-planet encounter. That ends this month's show. Join us again next month for the latest news from the frontiers of space exploration and commercial space flight. I'm Amanda Bush. Good night and ad astra.